Thank you so much. Good morning, everyone. I'm going to jump right in because I have so much time. So, most of what we know about language use and comprehension comes from college-aged and college-educated people. However, illiterate individuals represent a substantial proportion of the world population. So in order to fully understand language comprehension, we must then explore the role of literacy on language processing. Literacy, that is the ability of being able to read and write, confers certain advantages. And we can think of these advantages in terms of brain structure. For example, people with higher literacy levels tend to have higher levels of cognition. They have stronger specialization in areas that are related to language, and they have enhanced auditory processing. But there are also some social advantages related to being high literate. For example, those related to socioeconomic status. So people with high literacy levels tend to have better job prospects, higher income, and can participate more freely in upward social mobility. And so the idea here is that the invention of reading has changed the human mind, and these differences have been automatically carried out into many other domains and aspects of language use and language comprehension. The assumption has been that people with high literacy and people with low literacy behave differently. And so in terms of language comprehension, the assumption is that they process language in fundamentally different ways. And I would like to exemplify this with prediction, which is something that we do when we comprehend language. And you may have probably experienced moments in your life where you have guessed what other people are going to say. Specifically, when we hear someone read a sentence or speak, our brain doesn't just passively wait for each word. Instead, it tries to actively anticipate or predict the next word based on what has already been said. To give you a concrete example, imagine that you see this image and you listen to the sentence, "I drink my coffee with cream and." And if you were asked to guess the word that comes up next, you would be very likely to guess sugar. But if you see this image and you listen to the sentence, "The boy will move the," here, virtually any word can follow, and so it would be harder to make an accurate guess. So, prediction or anticipation is a mechanism that has been proposed in the psycholinguistic literature to facilitate language comprehension. And prediction is important because it makes language processing faster and more efficient. So by anticipating what is going to come up next, our brain can focus more on understanding the message and less on decoding every single word or every single sound. So in a way, prediction is like driving a familiar route. We don't really need to stop and think about every turn because we already know where we're going. And this is something that is well documented in the psycholinguistic literature, but there are differences between groups of speakers. For example, prior work has found that literacy-related skills, such as vocabulary size, impact the way that we process language. And the idea is that literacy changes cognition and brain structure by providing individuals with additional mechanisms through which they can process language. And just to give you an example, some studies using fMRI have pinpointed specific brain areas that are related to literacy. So hopefully, the idea that I'm trying to convey here is that when we learn to read, our brains change forever. And as a matter of fact, previous studies have reported a literacy effect during predictive processing, with lower literacy individuals not engaging in prediction or predicting later as compared to their higher literacy counterparts. Although studies suggest that literacy influences prediction during spoken language comprehension, we know that higher but also lower literacy individuals are exquisitely able to communicate with one another in many contexts, and they are also quite adept at taking turns during conversations, which can be considered a type of prediction. And what is critical about end-of-term prediction is that it occurs based on lexicosyntactic information. And this is an important observation because it suggests that both types of speakers can coordinate a myriad of factors to engage in anticipation. In this case, the process that allows speakers to anticipate when the interlocutor's turn will end. So why is it that we see this difference between higher and lower literacy speakers? When looking closer at the literature, we notice that prior psycholinguistic studies have not consistently considered social factors. More specifically, the role of socioeconomic status has been somewhat overlooked. And this is an important confounding variable because socioeconomic status is related to educational achievement, but also to cognitive and language development more generally. So it is unclear whether it is literacy skill per se or socioeconomic status that impacts the ability to predict. So to fill this gap, we conducted 2 experiments. The first one that I'm going to talk about examines the effect of literacy on spoken language comprehension using grammatical gender cues. Specifically, here we explored what happens when you present only one cue that is very frequent and acquired very early in life, and you also control for socioeconomic status. Do we still see a literacy effect? So we use grammatical gender in Spanish with masculine and feminine nouns. And grammatical gender is a linguistic feature that is highly entrenched in native Spanish grammars, and we also control for socioeconomic status as a potential confound. So perhaps in this case, literacy skill may not affect prediction during processing. So we took the lab to the field all the way to San Basilio de Palenque. It is an Afro-Colombian village located near Cartagena in the Caribbean coast of Colombia. And I realized that we're at a psycholinguistic conference, but I would like to add some sociolinguistic perspective to this and talk to you a little bit about the community that I work with. So the project focused on adult native speakers of Spanish with different literacy levels who shared the same socioeconomic background. And so you can see some images from the village here. Most palenqueros, the people from Palenque, are from low socioeconomic status. They live in what would be considered substandard living conditions. So most homes are made out of brick and tin roofs. Some houses have straw roofs. The streets are not paved. And the electricity and the water systems are very unreliable. Some of our participants reported receiving water only once or twice a week. As a result, they are farmers, they are construction workers. Now, it presents a very unique opportunity to control for socioeconomic status and literacy because we have some palenqueros who go outside, for example, to the city of Cartagena or to a nearby town, and they try to get, they get a technical degree or a university degree, right? But this is also a Afro-Hispanic community who has been historically marginalized, and they have trouble securing and finding a job. And so they are forced to come back to the village, and they end up working, preparing typical sweets and selling them in the other towns or as tour guides, etc. So I recruited 41 participants for experiment 1. And here we have some participants' characteristics based on education. I just want to mention 2 things real quick about this. When we think of education in Palenque, we need to think about rural education. And most participants completed high school through a weekly program where you just had to go to school once a day, and at the end you get a degree. And I interviewed some school teachers, and they all emphasized challenges related to reading habits, literacy, but also they stated that they needed more support from the educational authorities from Colombia as well. So there wasn't really a defined curricula in the local school. So the participants completed a series of literacy-related tasks, and with those scores, we conducted a principal component analysis, which allows us to divide the participants into higher and lower literacy groups. We measure socioeconomic status using 2 instruments. I'm only showing the results from one here. This is the MacArthur scale of subjective social status, and participants were asked to position themselves into one rung of this ladder, 1 being the lowest socioeconomic status, 10 being the highest, and we can see that irrespective of their literacy level, participants consistently identify themselves as being in the lower end of the socioeconomic status. We conducted a visual word eye tracking study with the participants, and since we were working with grammatical gender, we had 2 experimental conditions. The same gender condition where the 2 items in the screen shared grammatical gender, and the different gender condition where the 2 items in the screen differed in grammatical gender. So participants listened to sentences such as encuentra la or encuentra el, so find the, and they were asked to click on the name object on the screen. Crucially, we had a different prediction from each condition. So in the different gender condition, grammatical gender is informative. And so we expected participants to be able to use information from the article, from the grammatical gender in the article, to anticipate the upcoming noun, but not in the same gender condition where grammatical gender was not informative. We conducted a divergence point analysis to determine if there was a difference in the timing of fixations between the 2 groups. And what we see here are the results for the higher literacy group. In the x-axis, we see time in milliseconds, y-axis, proportion of fixations, and we also see some shaded regions in the background. So we have the article region, a pause that was inserted between the article and the noun, and the target noun region. So the red lines represent the looks to the target. So in a sentence like find the passion fruit, so we see, the target with the red lines, and then the black lines represent the distractors. All right, so the different gender condition is the solid lines, and what we see here is that as soon as participants have information from the article, they start launching anticipatory looks to the target item before its onset, but not in the same gender condition as hypothesized. All right, so this is for the higher literacy group. For the lower literacy group, we see the same pattern. They start launching anticipatory looks to the target item before listening to its onset here, but not in the same gender condition. All right, so in this experiment, both literacy groups anticipated target nouns before target word onset in different gender trials. However, there was an earlier divergence point in fixation patterns for the higher literacy group, which turns out to be significant. Although there was a quantitative difference, both literacy groups engaged in prediction at the earliest moment possible. These divergences in the timing of fixations have been reported in previous studies examining, for example, syntactic prediction. However, this result is not congenial with Mishra et al., who did not find prediction at all in the lower literacy group. They did use a combination of semantic, associative, and morphosyntactic cues to prediction. Specifically, they use noun-adjective pairings, but we know that higher literacy speakers have access to more varied input, higher quality input, but also to reading, and so they may have larger word associations and larger vocabulary size. And additionally, processing multiple cues in the input places higher demands on verbal working memory, which itself is enhanced by literacy. So considering the results from Mishra et al., who did not find prediction, it got us thinking, like, could it be the case that if participants have to update their predictions continuously throughout the experiment, that would then lead to an effect of literacy on language processing? And so in experiment 2, we examined whether literacy played an additive role in the time course of prediction, and we used a combination of semantic and morphosyntactic cues. A subgroup of the participants from experiment 1 completed that second experiment, which consisted again in an visual word eye tracking study. Now, we constructed different sentences. We were looking at prediction in 3 different regions: the verb region, a partitive phrase, and a determiner. And in addition, I would like to mention this: participants heard a background story before completing the task, just to situate it. And so for the verb, we use semantically constraining and semantically non-constraining verbs. That constraining verbs would apply to only some of the objects in the screen, but that non-constraining verbs would apply to every object. Partitive phrase, the partitive phrase further constrains the looks to only objects that have the property of being further divided into smaller parts, even with non-constraining verbs. And with that determiner, we were looking similarly as in experiment 1, same or different gender, masculine or feminine items, right? And so just to guide you real quick, I'll walk you through our predictions. When participants listen to my friend 8, we would expect them to only look at the edible objects. When they listen to the partitive phrase a little bit off, they should still be looking at the edible items. And then the last cue would be the determiner that gives away the target noun, watermelon in this case. However, when they listen to my friend gave me, they should be considering every single object in the screen. But when they listen to the partitive phrase, that should constrain the looks to the edible objects. And then again, the last cue would be that determiner. All right, so similar to experiment 1, we conducted a divergence point analysis to examine differences in the time course of fixations. And so at the top, we have the higher literacy group. At the bottom, the lower literacy group. And so what we have here in these graphs are the average looks to the 2 things that were edible in red, and then the average looks to the distractors in black. The solid lines represent the constraining condition, and the dotted lines, the non-constraining condition. All right, so for the verb region, this is just to remind you of our predictions. With constraining verbs, participants should anticipate the edible items, and that is what we see for the higher literacy group. When they listen to the verb, they start looking more at the edible items as compared to the distractors. But we see the same pattern for the lower literacy group, meaning that participants were able to make a prediction based on the semantics of the verb. For non-constraining verbs, the hypothesis was that they should be looking at every object, and that's what we see for the higher literacy group, but also for the lower literacy group, and there wasn't a statistically significant difference between the two groups and the processing of the verb region. For the partitive phrase, the hypothesis was that they should look, regardless to only the edible objects, than to the distractors, and that's exactly what we see for the higher literacy group and the lower literacy group when they listen to a constraining verb, but also when they listen to a non-constraining verb. And what this means is that they are predicting as they're moving through the sentence, and no significant difference between the two groups. And here things change a bit. This is more similar to experiment 1 for the determiner region. So instead of edible items versus distractors, what we have here are items grouped into same or different gender. Look to the target in red, look to the competitor in black. And so for the different gender condition, we expected them to use the grammatical gender in the article to make a prediction, and that's exactly what we see for both literacy groups, and no for the different gender condition, but no for the same gender condition as hypothesized. And again, no significant difference in the processing of the determiner. So the results from experiment 2 could be discussed from different perspectives. First, we have multiple cues reinforcing speakers' prediction. But we also we enhance or prioritize ecological validity by using first a background study to situate the task, but also we use sentences that resembled natural language use. And last but not least, we control for socioeconomic status, which plays a crucial role in shaping early language development. So to move on to the discussion and the conclusions, so given the evidence supporting the role of literacy in facilitating linguistic prediction, what differences might account for that divergent behavior between our participants and those in past studies? One possibility is the use of syntactic structures that are more commonly found in written language as opposed to everyday spontaneous speech. For example, Fabier and colleagues use passive sentences, but the comprehension of passive sentences correlates with self-reported hours of reading. So these may have placed the lower literacy individuals at a disadvantage. And other studies using active sentences also employed, for example, relied on familiarity with general word associations, which may have potentially favored individuals with higher literacy levels, given high literates, increased exposure to higher quality input and more varied input in general. Here, we examine linguistic features that were lexically encoded, grammatical gender, and the selectional restrictions of verbs and partitive phrases. And so the findings from the experiment suggest that in scenarios where prediction is anchored in highly frequent, highly familiar structures for the lower literacy individuals, the effect of literacy on prediction disappears. These findings are consistent with the enhanced literate mind hypothesis proposed by Hutton and Holstein. It is very recent, but this hypothesis proposes that all individuals, including low and high literate individuals, share a basic language cognition. And this basic language cognition includes all the linguistic knowledge that is common to speakers of a language, the core grammatical structures, and it is what makes possible everyday communication. And so, learning to read does lead to some enhancement, let's say the enhanced literate mind, right? But the core structures that are acquired in everyday interactions also play an important role during language comprehension. And so experiment 2 provides one of the first, if not the first, piece of evidence for these hypotheses. And the findings presented here suggest that when psycholinguistic studies prioritize structures that are widespread in spontaneous speech, then the involvement of processing mechanism by all individuals becomes more apparent. And so I do realize that disentangling literacy and socioeconomic status can be very challenging and has been very challenging. And so in that way, the economic and the social context of the speakers who participated in these studies afforded a one-of-a-kind opportunity and provide new insights into how literacy can be disentangled from broader socioeconomic factors. And so just to wrap things up, there are certain levels of language at which lower and higher literacy speakers perform at the same level. Of course, higher literacy individuals may have access to low-frequency structures such as passive voice, but they do share a common language base, which is created by repeated use of and exposure to language. The findings from these studies also highlight the importance of the social context and the importance of considering social background and the linguistic ecology of the communities that we work with. Prediction is not limited to highly literate individuals. And taken together, I believe that these findings offer a refined view of how literacy interacts with language processing. And in this view, literacy enhances the cognitive toolkit, but it is not the only influencing factor. So, what I'm trying to do with this work is, calling for a revised understanding of the role of literacy on prediction and on language processing. And of course, I'm not advocating for not encouraging literacy. That's the least thing I want to do. I do believe that we should encourage literacy, but we need to be very careful in overstating the benefits of being high literate to the detriment of what low literacy speakers can do with language. Thank you to my participants. Thank you.
Are you a student? I'm a postdoc, but it's okay. Go for it. Okay. Hi, I'm Sarah. I'm at Georgetown. Very interesting, very cool work, and kudos to you to making our work more inclusive and thinking about other groups. I really am interested in this last bit that you're talking about and thinking about, okay, they're engaging in predictive processing, and you look at and you see the effects that we would expect. But I'm also curious about maybe potential latency differences and why some people think that there would be this enhancement. So it could be the case that the enhancement comes from maybe having more frequent exposure to more complex structures, such that there might be an advantage at more complex structures, for example. But in this case, you're using some expressions that are going to be highly frequent or highly common. And so the question is would we still expect to see a latency difference? Maybe they're still facilitated by literacy, even though they're both both have high amounts of exposure to these frequent structures. I hope that makes sense.
Yeah, I think so. Thank you. Thank you. I mean, it might be, and I'm still trying to wrap my head around the significant difference found in experiment 1, which is, just grammatical gender. And so what I can tell you is that, it might, let me go back to that graph, because in there you can see a difference in magnitude, I would say. The magnitude of prediction, but the pattern is the same. So for the higher literacy speakers, we have that huge, oh, yeah, we're sure. And it might be the case that the lower literacy are considering all options a little bit slower. So that can be used, to explain this difference here. But then when we consider the results from experiment 2, I think that having your predictions confirmed by further linguistic input really makes that difference between the two groups disappear.
So this is where, if you could go back to experiment 2,
yes,
because that's where my question is coming from. I think what would be interesting is if you do see a time difference at which you would get differences emerge. Does that make sense? A latency difference of where you would see significant difference between where their looks are diverging?
Right.
Because it looks different between the higher literacy group and the lower literacy group in a way that I wouldn't expect. I would have expected earlier divergence for the higher literacy group and not the lower literacy group.
Right.
And so maybe something like a cluster permutation test will allow you to look at this difference and find where there might be a different time point at which they're going to diverge.
Thank you. I just took note of that. I did want to mention that here we see confidence intervals based on the first divergence point. And we have an earlier divergence point for the higher literacy group, but there's still a lot of overlap in these lines between the two groups. So that might be a better way to disentangle that. And Thank you.
Awesome, thanks.
Thanks.
Hi, Sarah Brown Schmidt, Vanderbilt University. I have a comment and a question. The comment is,
I love comments.
oh, good. Well, first, this was awesome. I
Thank
love
you.
this. The methodological rigor was really present here, and I like that a lot. The comment is that to be able to claim that there's that the magnitude of the literacy effect in the structures in experiment 1 is present and absent in experiment 2, you'd need to test for an interaction to show that there's a significant interaction between the kinds of structures you're looking across the 2 experiments and the presence of the literacy effect, if that makes sense. And I realize it's across experiments, so it's not ideal, but that's sort of an inferential comment. You're smiling. Did you do that test?
No,
Okay.
no. The reason I'm smiling is because I'm planning to go back to this community, and one of the benefits for me, maybe not for them, is that this is a very stable community. I went back like 2 years later, and I think 1 year later, and conducted experiment 2, and I was able to find still like most of the participants who completed experiment 1. So this is certainly a possibility.
Mm-hmm. Yeah, that's awesome. Okay.
Thank you.
And then the question is, and I'm going to channel Fernanda Ferreira here, but so there's, in the visual world paradigm, you're measuring more than just language, right? You're measuring the ability to sort of identify pictures on the screen, and from, say, a developmental perspective, it's bridging the sort of the other screen, or sort of the third wall of these pictures are representations of things in the real world. And so from a measurement perspective, the question is your literacy task also on the computer and requiring task skills that relate to responding to things on the computer? If so, I wonder if some of the variance in literacy that's explaining performance in experiment 1 is due to shared task variance between the kind of literacy tests that you were using and the need to do this visual world task on the computer.
So some of them were more like in paper. So, I mean, it might be interesting to look at that, but I do want to stress that we still found prediction. It's not like we didn't find an effect of prediction in experiment 1, it's just a quantitative difference in the effect of, in the magnitude of prediction.
You did great.
Thank you. I don't know how this goes.
Hi, Philip Resnick, University of Maryland. Thank you for, the work is great and your presentation was crystal clear.
Thank you.
Really more comment than anything else, a couple of weeks back, Mark Seidenberg and Mary Ellen McDonald gave a great talk at Planet Word, which people will be going to. And I think there's a really interesting connection here, kind of going in the opposite direction, right, of processing and literacy. Mary Ellen McDonald's one of her main points, right, what had to do with the exposure to what she called book language.
Right.
And what you're presenting here is actually really consistent with the idea that it's exposure, right, to relevant language in order to make appropriate predictions. Right? That is crucial, and they were focusing on needing to go beyond decoding to that. And one of the very interesting things that came out of that was her pointing out that there are other sources of book language than books.
Exactly.
Right? She was talking about things like BBC documentaries and other sorts of spoken things. So I just wanted to highlight the connection here.
Thank you.
Because I think what you're doing here is providing evidence that what we're talking about are not inherent cognitive differences necessarily, although peace to all of the things that still need to be done, but largely about exposure and the influence of exposure on prediction.
Yeah, thank you. Thank you so much. I agree.
Hi, Julie Van Dyke, Haskins Laboratories. So I'm really just following up from that theme, but first I want to say thank you so much for doing this work. I mean, we don't have enough studies of low SES and literacy in this type of community, so keep going back.
Thank you.
I think it's really important. My question is really about the literacy, the skill assessments that you used. I think especially, as Phil was saying, especially if you're going to look at prediction, we need to somehow measure reading experience or reading exposure. And there are reading experience assessments. I didn't see one up there, but maybe I missed it. But some like measures of how often are you reading, what types of text you're reading, that kind of stuff, and use that as a predictor to see if you might have literacy effects that way.
Yeah, I did try using a reading habits questionnaire, and here's the thing, like everyone would agree, that, it was like attitudinal, but also, what types of, materials do you read? And so everyone would agree that reading was important, and they would say, I read to my children, but then when I asked them, what type of materials do you use, it was more like, well, I read Facebook, or I don't own any books. right? So there are some materials that need to be adapted to that, to these specific communities that are low SES, because it doesn't really work with all. Yeah.
That's also an important place where you can make a contribution,
Yes.
is even just a way of sort of counting what types of materials they have access to and how often they're using those. So thank you very much.
Thank you.
I see there are more questions. I'm very sorry, but please enjoy them during the lunchtime to go back for a discussion. I'm going to continue on. Let's thank Jessica again for her presentation.